Thank you for joining us today. If you've heard about closed cell spray foam insulation and have wanted to specify it in a construction project, but still aren't sure if the information you have is based on rumors or facts, then today's webinar, Debunking Myths About Closed Cell Spray Foam Insulation, is exactly what you need. The goal for this webinar is to help you turn questions and assumptions into knowledge and facts so that you can specify closed cell spray foam with confidence. Let's start with a quick overview of closed cell spray foam, and then we'll review some of the myths you may have heard. Closed cell spray polyurethane foam insulation, also known as CCSPF, is spray applied on the job site during new construction or building renovations. CCSPF can be used to insulate exterior walls and as a roofing system. It can also be used to air seal and insulate wall cavities, crawl spaces, attics, and basements. Trained SPF contractors mix the foam ingredients at the job site. It's sprayed as a liquid that immediately expands to approximately 30 times its original volume. As it expands into rigid foam, it adheres and contours to the surface, filling in cracks and crevices that can cause air and water infiltration. With that basic overview in mind, let's take a deeper look by exploring CCSPF myths versus facts. Fact or myth? Closed cell spray foam doesn't meet air barrier code requirements. Myth. In fact, closed cell spray foam is a proven cost-effective means of meeting the air barrier and sealing requirements set out in ASHRAE Standard 90.1/2010, the International Code Council, and the Air Barrier Association of America. CCSPF is commonly recognized as an air barrier material at just 1-inch thickness and has gained wide acceptance as an air barrier in all areas of the building: roofs, walls, foundations, and floor systems, helping to make even the leakiest indoor environments more comfortable. A relatively rigid product once applied, CCSPF also provides thermal insulation, structural strength, and moisture protection. These air barrier and insulating properties are essential for comfort and energy efficiency. For example, as shown here, air leakage from the building envelope can cause wind effect air leakage by driving airflow through and around the building. Wind creates significant pressure differentials that can pull large volumes of air into and out of buildings, even if they are well insulated. The air barrier of CCSPF significantly reduces wind effect. An air barrier system using CCSPF also mitigates problems from stack effect that occurs as rising warm air creates positive pressure against the top of the building and negative pressure at the bottom. For example, during the heating season, the warmer indoor air rises up through the building and escapes at the top through plumbing, electrical, or ventilation penetrations or other forms of leakage. The rising warm air reduces the pressure in the base of the building, drawing cold air in through cracks, gaps, and holes that aren't sealed well. During the cooling season, the stack effect is reversed. Because CCSPF conforms to fill gaps, cracks, and holes, it creates an effective air barrier to drastically cut back these effects. Fact or myth? All spray foam insulation is the same. Myth. At a glance, closed cell and open cell spray foam insulation may seem similar, but the differences are quite vast. Open cell spray foam is significantly less dense and more spongy than closed cell. Plus, due to its open cells, it will absorb moisture, doesn't add significant structural strength, and isn't recognized as an air barrier material. In contrast, closed-cell spray foam can be used in all climate zones and is the preferred choice for many air sealing and insulation challenges, including severe weather and air barrier systems. CCSPF can add to structural integrity for enhanced performance during inclement and severe weather events. In fact, it is often used as a moisture control layer. Open cell SPF is susceptible to moisture absorption and is vapor permeable. It may require an additional vapor retarder and is not recommended for use below grade or flood-prone sites. Closed cell SPF resists water and is considered a Type 2 vapor retarder. It can meet 4 different barrier criteria: thermal, air, moisture, and vapor. This allows for significant design flexibility and often cost savings versus the additional detailing and products needed when open cell foam is selected. The U.S. Federal Emergency Management Agency, or FEMA, considers closed cell spray foam to be a flood damage resistant construction and insulation material. In fact, CCSPF is not affected by contact with moisture and is the only cavity insulation approved by FEMA as resistant to floodwater damage. That leads to another fact or myth statement. CCSPF is a cavity insulation only. Myth: because CCSPF is resistant to moisture contact, it's well suited for use on the exterior of buildings as a secondary layer behind the cladding or as an exterior layer with a finish coating. With the requirements for use of continuous insulation on the exterior of buildings by ICC and ASHRAE, using CCSPF on the exterior is a cost-effective means to achieve this requirement. In fact, when used in this configuration, CCSPF meets the requirements for moisture, vapor, air, and thermal bypass control. This is often referred to as the 4-barrier system or the perfect wall, since, as designed, it can be used in all climate zones with little to no modification. We've already busted the myth that CCSPF can't be used for roofing. In fact, that's about as wrong as a myth can be. Closed-cell spray foam roofing systems offer heightened durability and sustainability, along with moisture resistance and energy conservation. CCSPF is a popular component of reflective roofs, or to underlay green or vegetative roofs. In addition, it's uniquely suited for roofs with unusual shapes and is effective for retrofitting buildings to current ASHRAE standards. In commercial roofing applications, CCSPF helps address air barrier challenges that result from mechanically fastened roofing systems. While a roof membrane system can be considered an air barrier material, it's important to note that only fully adhered and continuous roof systems are effective as part of the entire building envelope air barrier system. CCSPF provides a continuous layer that seals roof penetrations and is applied as a single monolithic layer. The benefits of CCSPF compared to other roofing systems are clear. Mechanically fastened, build-up roofing systems, or ballasted roofing systems are generally not considered effective when looking at the entire building air barrier system. Such roofing systems may result in air and moisture being moved into and out of the building from areas where air leakage occurs, such as roofing penetrations, fasteners, joints, cracks, and other openings. Consequently, another air barrier system is often required to complement mechanically fastened and ballasted roofing systems, adding additional material, labor, and scheduling costs. CCSPF not only provides the air and moisture barrier, but its strength in severe weather stands out. Because CCSPF is self-adhering and fills cracks and crevices, it helps prevent air leakage in roofing systems and provides excellent wind uplift resistance. In severe weather, wind uplift occurs when the wind grabs the edge of a roofing material and lifts it off the deck, or literally peels back portions of roof. That superior severe weather performance leads us right to the next fact or myth. Insurance companies will not insure SPF roofing systems. Myth. Just ask the folks at the Cleveland Airport system, who selected a closed-cell spray foam roofing system for 500,000 square feet of roofs over 2 airports. Cleveland Airport is insured by FM Global, and the roofing system met their stringent requirements for severe hail. Because the roofing components were approved by FM Global, the airport saw a decrease in their insurance premiums. In addition to receiving the severe hail rating, the same system used at the Cleveland Airport met FM Global's requirements for wind uplift, flammability, leaks, foot traffic, and corrosion performance. Fact or myth? Since CCSPF is a vapor retarder, it can't be used in warm climates. Myth. CCSPF can be used in all climate zones with no restrictions. In warmer climates like zones 1 through 4A, The use of a vapor retarder is optional. The problem with traditional membrane vapor retarders is that they're located on the wrong side of vapor-permeable insulation for much of the year, which can result in limited drying and condensation issues. Because the vapor retarder properties for CCSPF are inherent to the insulation layer and CCSPF is an air barrier material, the vapor retarder is located on the correct side of the wall, effectively eliminating the drying and condensation concerns. In addition, where vapor retarders are required, CCSPF may offer some design cost savings compared to vapor-permeable insulations. As you've seen, when the myths are replaced with proven facts, all spray foams are not created equal. Closed-cell spray foam insulation is a superior choice for a wide range of applications. In summary, closed-cell spray foam is an effective air barrier and a cost-effective way to help meet air barrier code requirements. Closed-cell spray foam R-value represents an aged material performance, so you can rest assured the product will perform as designed. Closed-cell spray foam can be used as cavity insulation or applied to the exterior of a building as a secondary layer. Closed-cell spray foam is an effective and energy-efficient roofing system. Closed-cell spray foam roofs are insurable, and in some cases, premiums have decreased as a result. Closed-cell spray foam can help you meet federal and local mandates for energy reduction and environmental standards. And closed-cell spray foam can be used in all climate zones with no restrictions. Another reason to specify closed-cell spray foam is that you have a choice when it comes to the blowing agent, which is what makes the foam expand and provides the insulation value. If you have safety and environmental concerns, consider requesting a formulation made with Honeywell Solstice liquid blowing agent, which has ultra-low global warming potential, is considered VOC exempt by the US EPA, is non-ozone depleting, and is non-flammable. To learn more about the many advantages of closed-cell spray foam and Solstice liquid blowing agent, talk to a professional SPF contractor or visit honeywellblowingagents.com. Thank you for attending this webinar, Debunking the Myths about Closed-Cell Spray Foam Insulation. I hope you consider specifying it as a thermal, air, moisture, and vapor barrier system for your next construction project, or to improve the energy efficiency and performance of an existing building.